And here we're looking at some of the things that we can do in terms of how we can take advantage of the get count function. And again, it's important that we're able to do a statement like this. So notice the very beginning here, we have the cout statement that says number of employees before instantiation, or meaning before we've created any objects, is, and then we do a call to the get count function. And we haven't even created any objects yet, but that's fine. But so the way that we're calling this is employee : get count, right? So we're just using the scope resolution operator, but this time we're using it in the application program. So that's where that whole expression global to the class, right? You hear that come up a lot, that, that this static number variable is global to the class. And that's exactly why we use that kind of wording or that kind of phrasing, because it is going to be shared, right? So even if we did use an object to call get count, it's not going to change anything, because there's still only is physically one copy of count in memory, and you're always accessing that one entity or that one data value from memory. So it is possible in that sense to also um, call it with the object, but it doesn't really help us in any way to do that, because it's the same as just calling it like what we're doing here with the scope resolution operator. But we just have that realization that our static data or static variables are global, right? Global to the class. So we can certainly call it like that, and that's usually how we would go about calling our corresponding static functions. So a question about, as long as we include the employee class, we can use the static variable like a global variable. Well, it's still something that is within the class. It's not not a global variable in the sense of like doing a global variable declaration at the top of main, and then you can access that anywhere. And then also the variable is still private, so we still can't, like, for example, go in and directly change counts value in main or the application program. because one of the important things that's hit on in 110 and 165 is the problems with global variables, right? And why you should really always avoid using them. Because with the global variable, the whole idea is that you can change it directly anywhere in the program. So even if you've divided the program up into all these different functions where each function is doing a different task, which you should be doing, right? But if we have a global variable, that can be changed anywhere. And so that's going to make things like debugging and all that harder, right? If there's a problem that we have that's somehow related to, and by problem we mean some sort of bug, but if you have a bug related to that global variable. But things like global constants, right, are okay because you, of course, can't change them. So in the case of what we're doing here, we did still, because of encapsulation, right, we did still make the variable private, the static variable count private. And also there was no, in this case, there was no set type function, right? There wasn't a static set type function because we want to control how we're changing that static variable's value. And since the idea was that it's going to be keeping track of the count in terms of when objects are being created or destroyed, right? We don't want the user to just be able to go in and, say set count 500 if there's only one object that exists. So that's why it's very limited in terms of what the user can do, right? They can call the get count function at any time, but the actual changing of count strictly takes place inside of the constructor and the destructor for the class. So the application program does not have the direct ability either through accessing the variable directly or through a set function, because the variable is private, and then we simply did not include a set count type function. So it's very restrictive in terms of where it can be changed. What's the difference in... Right, okay. Yeah, it's a similar idea because things like cout and cin are part of that name, the standard input output namespace, which is where we have definitions for things like cout and cin. And so yes, if you're not using that using declaration, then you have to individually tag things like cout and cin with the std : : and so it's a somewhat of a similar idea, because in both cases the : means scope resolution operator. In that case, though, you'd be referring to std, which is where we have definitions for things like our console input and console output. So if we don't have the using declaration, then we do, yes, have to go in and individually tag all the couts, for example, and the cins with std in order to be able to use that. Mm-hmm. And it's a similar idea here in terms of calling get count, right? If we're not calling it with an object, then we can't just say get count, because we have to know that we're trying to call the get count function in the employee class, right? Because in general, we could have an application program that's working with functions at different scope levels, and it's just not going to, it's not going to just automatically know that what we're trying to do is call get count inside of employee. So when you're using an object, that's not needed, because of course the object is of that class type. So when you say object name dot function name, it knows to call it in the class. But if you're not using an object and you want to call it, which we can do if it's static, then we do need to use the scope resolution. So that operator is always there whenever we need to indicate what scope level something is coming from. Mm-hmm. So that's our first cout statement, or our first call to it. And that's before we've created any objects here in the application program. So we would see 0 there. And then we create a couple of objects, and this is at nested scope level. So we have that curly bracket here. We create a couple of objects, and then we call it a couple times here. And this just kind of demonstrate the point. So we called get count first with the scope resolution operator. And then we called it with this object E1. But it's just, both are just going to give the same result. So there's not really, right, any advantage or anything like that to calling it with one of the objects. And again, it does just kind of makes it more clear in terms of distinguishing it from the regular variables and regular functions, the fact that it's static, right? So it's also a good idea to just kind of follow that as a convention and use the scope resolution operator to call your static functions. So we print it out twice here to see the number of objects at this point. And then here we just print out the employee's first name and last name. And then at the end, after we hit that right curly bracket and things have gone out of scope, then we call get count again to see what the count is going to be at that point in time. And the idea again is that we just want to see, we just want to be able to see how it's changing throughout the lifetime of this program. And then that's our output. So at the beginning there, we have number of employees. In the beginning is 0. So that's when we called it before any objects were created. And then we see some of the output statements for when the constructor was being called. And then in that curly bracket, that was in the nested scope level, that was where we created those 2 objects. And then we printed it out 2 times, once using the scope resolution operator, the second time using that object E1. And so we get number of objects after is 2, 2. So printing out the fact that there's 2 objects, and we're printing it out twice in that case. And then we have the names of the 2 objects being displayed, which was also part of that block that we had in the nested scope. And then we see the destructor, also the destructor outputs when we hit that right curly bracket and the objects go out of scope. And then the last thing here is that final cout statement that was after the right curly bracket that says number of employees after objects are deleted, and then we're getting the value 0 there. So that's just showing you the idea here in terms of how this is working. So we've seen now really what the idea with static is, and it really is a good idea to use it when we're able to do so, such as here, and also with things like assignment 6, right, with the faces array and the suits array. It was a similar kind of idea, because you were going to have that deck vector, right, and with all your different card objects, but you don't really need to store the list of the faces and the list of the suits for each of, of the 52 card objects, because they're all the same, right? That can be shared across all card objects. So the whole idea was that, you could make those two arrays static, and then your member variables for the face and suit were integers, and then you were just going to use those as indexes, right, into the faces array or the suits array to ultimately build a string like ace of hearts, for example, and so on and so forth. So that was another case where we could also use the keyword static. And one of the other benefits of doing that, again, is in terms of memory, because we know that anything that's not static is going to be stored individually within each object, right? So for example, if the arrays are not static, then you'd be storing the faces array and the suits array with all the 52 card objects. But if you make them static, then there's only one copy of each, which certainly saves on memory. So it is good in that sense also from a memory standpoint to make things static when you're able to. And you're always going to know whether that's possible or not by just thinking about the data and answering that question of, well, is this something that we need to store separately for each object, right? Are there going to be different objects that have different values for this variable? Or is there just one version of it, just one copy of it that's going to be shared by everything? Because if the answer is yes, then that would be an indication that we can, that we can make it static. And then when that happens, as we saw here, in some cases that also leads to it being convenient to have a corresponding static function. So the good thing about having that get, in this case, get count function be static was that, we were able to call it without having to use an object, right? We showed both ways, right? Both ways were possible. But the idea was that we did not have to necessarily use an object to call it, given that the function was static. So we were able to just call it directly using that scope resolution operator. And so that's why in some cases when we have static member variables, we also will in some cases have corresponding static functions to work with those static variables as well. And then here, if we don't have that function be static, if we just made get count, a regular member function, then we also can't do this kind of thing, right? Meaning we can't call it with just the scope resolution operator. So that's really a key reason why we would want a function also like get count here to be static, because we do in general want to be able to, call it without having to use an object. So again, even if the function's not static, we can still return count, going back to the point earlier I made that, that non-static functions can access static variables, but then in the application program, right, we can't call it the way that we would really ideally usually call it, which would be calling it without an object. So that's why when you want to directly refer variable like that, we want to really have that corresponding function be a static function. Okay. So any questions so far? Okay. Okay, well, that summarizes the key points here about static. And so now we'll talk about operator overloading. So static was the last major topic here in chapter 9. And so the whole idea really with operator overloading is to be able to use the operators with class types similar to how we use them with primitive types. So we're doing, more work on the class side of the code in order to have less things that we have to do on the application side. And so to start with here, we'll look at a class called coord, which is short for coordinate. It's going to have two member variables, x and y, right? So x for the x coordinate, y for the y coordinate. And we're just going to look at the basics in terms of how to overload a lot of these operators. And then we'll look at some other examples with some more advanced examples throughout the rest of chapter 10 as well. But really the idea is when you're going to overload an operator, you always want to think about how it's going to actually be used. And so in terms of this coord class, we're going to be overloading a lot of the common operators, such as, the plus operator, for example, to do addition, or minus to do subtraction, equal to do assignment, or plus equal, and so on and so forth, right? And really the whole idea is that all of these operators are really just functions, right? When you encounter an operator in C++, like the plus operator or the assignment operator, right, you're really just doing a function call. And so we're going to want to be able to support several kinds of operations here. And when you think about things like addition, we're going to want to be able to do things like add two coordinate objects together, or potentially add a coordinate object and an integer together. And along the way, we're really going to see how you can think about the process here. Because part of it is thinking about really, what are the different things that we want to support here? Because there's several things that we're really going to end up supporting with this coordinate class. And along the way, we'll see different combinations in terms of what's possible, right? Because a lot of these operators can be overloaded in two different ways: as a member function of the class, which is what we're used to doing a lot of, and then also as a friend function, which we briefly talked about that idea in chapter 9 when we learned about the keyword friend, and we looked at that example with the setX function and main and making both of those friends. And we know that the keyword friend allows some code outside the class to directly access the private members of that class. And so what we're going to do is we're going to look at a lot of the different combinations. So in the coord class, there's going to be several things that are commented out. The idea being that when you are overloading a particular operator to do a particular thing, such as add two coordinate objects together, or maybe add a coordinate object first and an integer second, right? You're going to choose one way to overload it, right? And you're going to have one way active. So for that reason, there's going to be several things commented out so we can see all the different combinations, but they're not going to all be active at the same time, right? Because when we think about this whole concept of operator overloading, we're recognizing that operators are really just functions. And so just like you discussed before about overloading a function, one of the key things there is that when you have functions with the same name, that there's no ambiguity. And so you still want to think about those things in terms of operator overloading as well, right? Making sure that when you're writing out an expression in the application program, that's only going to match one function call, right? One overloaded operator function call. And so we'll make sure that we do that in the chord class, but we'll see with some of the things that are commented out, how you could also do it an alternative way as well. Because with a lot of these combinations that come up, we can do it in terms of either a member function or as a non-member friend function. And there will be some exceptions, right? There'll be some cases where we'll see, for example, it really is going to need to be done as a friend function. So we'll eventually look at things like the input and the output operators and see why those particular operators are always going to be overloaded as friend functions. But a lot of the operators that come up in general can be done really either way, right? As either a member function implementation or a non-member friend function implementation. But again, the starting point, even before getting into all the details here, and because we'll see in terms of the syntax, a lot of these functions are actually going to be very short. Some of them will be a little bit more involved than the others, and we'll talk about why that is along the way. But most of these functions in the chord class are actually really short, right? There's a lot of them, but there's not that many statements within the actual body. And because the idea is that with this realization that operators are really just functions, right? And so each operator is a function, and the name of that function is the word operator followed by the symbol for that operator. So if we want to implement a overloaded plus operator, for example, to use for addition, then that would be a function that's named operator plus. If we want to do a overloaded multiplication operator, meaning the star, then that would be a function named operator star. If we want to do the assignment operator, which is something that we've talked about a lot throughout chapter 9, when we talked about things like default member-wise assignment, right? We said that was why you could do things like time T1 equals T2 if they're both time objects, and that would copy the hour, minute, and second from T2 to T1. We said that was because a class includes a default overloaded assignment operator. That's one of the few that is provided by default, right? Most of these operators are not provided by default, which means that the only way you can use them is if you actually include them, right, in your class. The assignment operator is one that is provided by default, but like anything else that's provided by default, you can always override it with your own implementation, and sometimes we really will need to do that, as we'll see, especially with one of the later examples later on in chapter 10. But we'll look at what it's going to look like here in the case of the coordinate class. But that would be a function named operator equal. So each function, each operator is just really a function with the word operator, and then followed by that symbol. And then from there, it's just a regular function, right? So we have to think about the usual things like what's going to be the return type, what's going to be the parameter list, and then what's going to be happening in the body in terms of the actual logic of the function. And in some cases, it's going to be done in terms of a member function. So meaning in our, as usual in our CPP file, we'll be using the usual scope resolution operator, just like we would with anything else that's a member function that's defined in the CPP. In other cases, it might be a friend function, meaning it's not a member of the class, but it is a friend. So it'll also be written out in the CPP file, meaning the core.cpp file. But of course, it won't be using the scope resolution operator, but it will be declared as a friend, so it'll be able to access members of the coordinate class. And But there's several things that we're going to want to be able to do in general, right, with this coordinate class. So we'll look at some brief examples here before we start getting into the actual code. Because what's going to really happen here is we're going to actually be overloading some of these operators several times as opposed to just once. Because there's going to be several different combinations that we want to support with some of these operators. So usually, right, these are going to be the two things that come up, overloading it as a member function and overloading it as a non-member friend function. And we usually would make it a friend if it's not a member, just so that way inside the function, we can still directly access the private members of that class. And again, the benefit of doing all this is that we simplify things in terms of the application program. So the chord class itself is going to have just two member variables, x and y, x for the x coordinate, y for the y coordinate, and we'll just have those as integer types, so whole numbers. But there's going to be several types of things that we're going to want to be able to do. One of those things is going to be adding two coordinate objects together. Now, when you think about the application program, based on everything that we've learned so far, right, you could think about, for example, having, a set function for x or maybe a set function for y, and then you could change x and y individually that way. But the whole idea with operator overloading is now we want to be able to use these operators that we're familiar with, meaning like the plus operator, and we want to be able to use those directly with the objects, right? So instead of having to say, assuming we've put an object chord C1, instead of having to say things like C1 dot set X 5, or something like that, we want to be able to just directly add them together. So if we have two chord objects, we're going to be able to do things like add them together and then maybe have, for example, another coordinate object store the result or the sum of the two. Oh, yeah, I mean, we just use the term overload here because it's kind of similar to, in general, function overloading, because operators are functions. And in some cases, we will have, for the same operator, because remember, the name of the operator function is just the word operator and then the symbol for that operator, like operator plus. And in general, we may have multiple functions named operator plus, depending upon what exactly it is that we want to support. So yes, it's in line with the idea of function overloading, but now we're applying it to the concept of operators. So that's where that term really comes from. Yeah, yeah. Yeah, so it just, yeah, it means overloads in the sense of having multiple versions potentially of the same operator. So, we're talking about adding two coordinate objects together as an example and storing the result in a third coordinate object. And I mean, certainly you could do that also with having the right functions. So perhaps something along these lines where doing something like C3 dot set X variable and then get C1's X, value of C1's X, value of C2's X, and then add them together, either using a plus type expression or maybe an separate add function or something like that. And then doing the same thing for Y. But the point is now we want to be able to use the operators similar to how we would use them, think about using them with primitive types, meaning with things like integers. But what we really want to be able to do is a statement like this, just C3 equals C1 plus C2. Oh. Yeah, well, what we're gonna eventually see, yeah, when we look at this chord class is, so we know that the functions, I mean, exist independently of the objects, which is why we have only, when we write out a particular function, there's only one copy of it, right? As opposed to storing it separately for each object. But it means that we can, yes, have multiple functions with the same name, but applying that idea now to these operator functions. So we could potentially have multiple functions active at the same time that are all called operator plus. And it follows the usual rules of function overloading, which just means that there has to be a way of distinguishing them, right? Meaning there has to be a difference in terms of the parameter list. So that's really what we mean by overloading. Mm-hmm. And so a statement like this is really involving two different operators then, and meaning also two function calls. One is the call to operator plus with C1, right, and C2 as the two operands, and then that's going to return a result. And then we do a second function call to operator equal, which would have C3 as one of the operands and the resulting chord object is the other operand. So really two separate function calls are taking place, right, to do a statement like this. And so we'll see that the way that this works is, for example, we do a statement like this, then C1 would be the left operand, C2 would be the right operand. When we do a call to operator equal, then C3 would be the left operand, and then this resulting object that's returned from C1 plus C2 would be the right operand. So these are examples of binary operators, right? They take two operands. And we'll look at some of the different combinations that are going to be possible here. But so when we do a statement like this, right, C3 equals C1 plus C2, and then we're assuming that we started with declaring these three objects, the whole idea in terms of what's going to happen when we call this plus function is we're going to add the x coordinates together, and add the y coordinates together, right? So here when we create objects C1, C2, and C3, C1x is 2, right? C1y is 3, C2x is 4, C2y is 5, and that's all going to be reflected in C2 now, or C3. And likewise for the y coordinate, you'd have your 3 plus 5 equals 8. Now, we can also, because I mean, again, we're thinking about how this is similar to primitive types. And with primitive types, meaning things like type integer variables, you can also in general have very long and complex expressions, right? All on a single assignment statement, right? So you can have more than just, for example, a single plus. So if we had even more coordinate objects, right, we could, for example, in general, do things like this. And also combine other operators, right? Like, for example, multiplication or subtraction. But we can, in general, have, complex expressions. And we'll eventually see how this is all going to work and how it's going to come together. Because we know that, again, these are all really just function calls. So when we're evaluating an expression like this, right, we do function call to operator plus with C1 and C2. And then we're going to use that result along with C3 to do another call to operator plus. And then that result and C4 to do another call to operator plus. And then that final result and C5 to do a call to operator equal. And so one thing that you also can think about here is, well, how is it going to be possible to have multiple coordinate objects like this and multiple operators like this all on the same line together, like C1 plus C2 plus C3 plus C4. And we'll see that it comes down to thinking about the return type of the function. Because this is really something that we've seen before, right? Earlier in chapter 9. We saw it in a different way in some sense, but it's the same idea coming up here again. And any thoughts on what that is? Well, because what we're really doing is we're chaining several of these function calls back to back on the same line. But that's also exactly one thing that we looked at in chapter 9. When we talked about cascading number function calls, using things like the dot operator or the arrow operator. It's the same exact idea here, but in terms of operator overloading. So we'll see that issue come up once again, because that's something that you always want to think about, right? Because in general, we do want to be able to chain things like this into a larger expression. So C5 equals, and then we're going to do all of this first before we can actually call the operator equal. And so that's the basic idea. And by doing this extra work on the class side, right, meaning by actually writing out these overloaded operator functions, we're going to be able to significantly, right, simplify things in terms of application programs. So we're going to be able to use these overloaded operators in a very natural, intuitive way, because we're going to be using them similar to how we use primitive types. And so we've been hinting that we're going to look at overloading in terms of two ways for most of these operators. One is overloading as a member function or as a non-member friend function. And so the idea is that we've been hinting that each of these statements here, like the C1 plus C2, is an actual function call. Now, of course, we're wanting, in terms of the application program, right, we're wanting to write these out as more like expressions, right? So we normally don't write them out in terms of an actual function call syntax in the application program, although that's something that you can do, as we'll see. But it means that a statement like C1 plus C2 is really a function call to a function that's named operator plus. And what that function call looks like really is going to depend upon whether it's implemented as a member function or as a non-member friend function. And in fact, this kind of thing could be done either way, meaning the case where we're adding two coordinate objects together, such as C1 plus C2, that could potentially be done, meaning implemented either way, as a member function or a non-member friend function. And so if it's a member function, then it's going to look like a statement like this, meaning the object on the left-hand side, and then a dot operator, and then operator plus, which is the name of the function, and then in the parentheses, the object on the right side, right, which would be the value on the right-hand side of the plus operator. So assuming that, because this is really one specific case of operator plus, this is the case where we're adding two different coordinate objects together. And as we'll see, we're going to return a new coordinate object. If we've overloaded that version of operator plus as a member function, then the corresponding function call is going to look like this statement here. So C1 dot operator plus and then C2. On the other hand, if this version that adds two coordinate objects together was overloaded as a friend function, then it's going to look like this with no dot operator, right? Since in this case, it would not be a member function. So operator plus and then both C1 and C2 as the two arguments that are passed in. And this also leads us to kind of a key realization here, is that when we're looking at the different possibilities in terms of how we overload it, one thing that we are seeing here is that when we have a choice of overloading it as either a member function or a friend function, the parameter list for the member function version is going to be shorter than the corresponding friend function version. And it goes back to things like the this pointer, which we've talked about before, because we know that with every non-static member function, the first parameter that we really have behind the scenes is that hidden this pointer, which points at the current object. And we said that that is never something that we have to write out explicitly. And so that's why if we're doing a function call like this, right, C1 dot operator plus C2, well, when we're inside of operator plus from that function call, we know that this pointer is referring to C1. And so in terms of what we actually have to explicitly write in the argument would just be the other object, right? In this case, C2. Whereas if it's a friend function, of course, there is no this pointer because it's not a member function. So we would have to individually pass in both C1 and C2. So that's one of the benefits, right, of using the member function version when possible, is you do, reduce the number of arguments that you have to write out, or the number of parameters that you have to write out, because of what the hidden this pointer is doing for us. And that also leads back a little bit to our previous discussion on static, right? So we talked just about static variables and static functions. And when we're talking about overloading an operator, that is going to always be a non-static function, meaning a regular member function. Because as we're seeing here, I mean, the whole idea is when you're calling a overloaded operator function, there's always going to be at least one class object that you're working off of, right? So it's not a valid thing to try and, call operator plus with the scope resolution operator and no object, because a overloaded operator is always going to be working over at least one object. So whenever we overload a operator as a member function, it's always going to be a non-static function. So because it always is going to be working with at least one class type object. And so that's one thing that we'll also take into account with this chord class. So whenever we have a choice, we'll have the member function version be the active one, and the friend function will be commented out, in part because of this, right? Because the parameter list is more concise for the member function version compared to the corresponding friend function, because of the work that the hidden this pointer is doing for us. So really, again, a lot of this hits back on points that we've seen before come up in chapter 9. But so that's why, for example, here, we only had to pass in C2 if it was a member function. But if it was implemented as a non-member, then we do have to pass in both C1 and C2 separately. And this was the other key point here too, is that if it is overloaded as a member function, then it's going to have to be non-static, right? Because it's always going to be working with at least one object. Now, here we were looking at one particular case that comes up in the core class, which is where we're doing an addition operation between two different coordinate objects, meaning that on both sides of the plus, we have a coordinate object for both of the two operands. Now, you could also have a mixture, meaning we could have one of the operands be a coordinate type and the other could be, for example, a primitive type, right? They don't necessarily both have to be, they don't have to necessarily both be coordinate objects. So we can do things like addition between a coordinate object and a single integer, as opposed to adding two coordinate objects together. And that's going to have a different meaning if we want to do that. So we saw that the meaning of operator plus in terms of when we had two coordinate objects was that you were going to look at the x parameter of both objects, add them together, and in this case, store them in the other object, or C3 if we're talking about this example up here, right? We were going to add C1's x value, C2's x value, store the sum of that in C3's x member variable, and likewise add C1's y value, C2's y value, and add those together and store that in C3's y value. And that's certainly something that we want to be able to do and support. And so that's one version of operator plus. We would call that the version that adds two coordinate objects together. But there are other versions that are going to be possible to include as well. But there's actually some other things that we're going to include here as well, beyond just being able to add two coordinate objects together. So another thing that we're going to include in this core class is the ability to take a single coordinate object and just an integer value and do addition between those two things. And what that's going to mean in the context of the core class is if we're adding a coord object and a single integer together, we're going to take that integer and we're going to add it to both of that object's x and y values. And then we can use that result. So we could do things like, for example, C3 equals C1 plus 5. And then that would take C1's X value, add 5 to it, store that in C3, for example, .x, and then take C1's Y value, add 5 to it, and then store that in C3 .y. So that's another thing that we're going to do as well. And then after the break, we'll talk about the different combinations that will be possible here. So what's going to end up happening though, and this is all for just one operator, right? Which is why there's going to be several different functions or operators in the chord class, because some of them do have multiple versions, right? And what's going to ultimately end up happening here is we're going to have 3 different versions of operator plus for addition. One for handling the case of adding 2 coordinate objects together, one for handling the case of adding a coordinate object first and an integer second, and then a third one for adding an integer first and a coordinate object second, right? Because these two cases here correspond to 2 different functions, but they all have the same name of operator plus. So we'll make sure in the chord class to ensure that they have different parameter lists, which they will. So we'll have a total of 3 different versions of operator plus for addition active to support all of these different things that come up, whether it's adding the 2 coordinate objects or coordinate object first, integer second, or integer first and coordinate object second. So we'll be able to support all of those combinations that come up. And but we'll also along the way see a case where sometimes we do have to really overload an operator in a certain way, which we'll see that after the break. So we've been kind of building, we've talked about the high level idea, and then we'll start to get into some of the specifics here in terms of the chord class as we work our way through that class and look at the various operators. So any questions here before we go to break? Okay, we'll take about a 12-minute break, 12-minute break till 1:06. So a 12-minute break, and then we'll come back at 1:06 and continue with our operator overloading.